So all this is having some kind of accounts. Yeah, so there are user and process accounts within the operating system. So if you run a process, it is inheriting your permissions. Yeah, so it's virtually run with the same user account as you have just logged in into the operating system, right? So how you are getting a hold of this user account. Yeah, so in the operating system there are different so-called users. Yeah, so there are not physical users, but these are like handles, the usernames, protected normally by passwords, and additionally by smart cards or some other means of multi-factor authentication. Yeah, so in Windows, these records of security accounts are stored in a separate database, a highly protected database file, SAM, that is hidden deeply in the Windows directory. You can find it easily, but you cannot read it without special permissions, and it's quite encoded in within, right? So you will not be readily provided with all the information, but there are tools. Yeah, there are tools to extract readable information, so-called hashes of passwords and the usernames that correspond to them for further analysis. Yeah, and there is this difference between the older hashes version, the older hashing mechanism version, and the newer hashing mechanism version in the Windows operating system. So previously it's been really weak, really silly, I would say. Even so, it was like really easy to hack, right? So maybe in the very beginning there were no such processing power available to everyone, and it would take much time, but currently older versions of Windows are not just are not even just not recommended. They are absolutely insecure to use. These things like Windows NT version 4 or Windows 98. Yeah, so they are using this older implementation of landman hashes and NTLM version 1, which are really weak. So now in modern Windows environments and in Active Directory, it is strongly recommended to default to this more secure hashing scheme, NT-Landman version 2, which is free of all these vulnerabilities of original Landman hashing scheme. Okay. Now, what are different vulnerabilities? Yeah, and the ways to exploit those vulnerabilities that are prevalent in Microsoft Windows and the processes that are run in it. Excuse me. So, first of all, there is this class of memory corruption vulnerabilities. This is the holy grail of Windows exploitation in the 90s. So these errors were so prevalent that that pushed Microsoft to completely change their approach to software development. And closer to 2004, all the process of software development has been completely reformed, and this new methodology of SDLC, right, Secure Development Life Cycle, has been created, and it's used until now. However, we are not really aware of what's going on and how it changed with time, but the effect of this methodology has been fascinating, right? So for example, there is this metric of time to first remote exploit in the product that passes after the product release until the exploit is discovered and the exploitation starts in the wild. So normally it would take from a couple of weeks to a few months, right, for the hacking community to find remotely exploited vulnerabilities in newly released Windows systems or other Microsoft products. But in the first product that has been released and developed according to SDLC, that was Microsoft SQL Server 2005, I guess. This time was more than a year. Okay, so Microsoft SQL is vulnerable in many other ways. Yeah, so operational security of that product is really poor, and this is the bad thing. But from the standpoint of memory corruption bugs, it was really the state of the art, the bleeding edge of protection against existing hacking techniques that have been effective until then, and many years after, because Windows has this backward compatibility. I stopped myself from saying issue, but yeah, this is tradition that all the functionality that has been implemented in previous versions has to be supported in the next versions. But yeah, that slowly but surely they have been increasing their security level, and in 2016 we can finally say that this is the year when Microsoft bugs are not the most prevalent on the internet. Yeah, there are now Adobe, Java, there are even Linux bugs in desktop environments and so on. But Microsoft has strengthened their positions in this area, right? So what did they do? They have reformed the approach to development. So now there were these stages of manual or automated code review. There were these security architecture meetings and reviews in the beginning of each product cycle. Yeah, so every time some new feature is added, there were some meetings of experts that have decided upon the implications that this functionality or these technical changes introduced for the security of the product. So that was really interesting. These new practices combined into the whole methodology with very broad vision were really cool. So what they were aimed against, right? So what has forced Microsoft to make such a dramatic change? First of all, you may know how programming technologies, programming languages have evolved. So in the beginning we had this really low-level programming that with time has become more abstract. So assembly languages have appeared, yeah, and after that we have created C programming language, and then it transforms to C++ that introduced object-oriented paradigm of programming. And in parallel there were many other trends, and there were many other purposes of programming, of practical programming, application programming, system programming, and so on. So there were really a lot of different paradigms, modular, object-oriented, linear, and so on, and there were different approaches to running code. So some code were pre-compiled and stored in binaries and run whenever user needed that. And some code was just stored in text files and compiled before execution into the memory, so the binary file wasn't really stored anywhere between executions. Yeah, so scripted and compiled programming languages were the trend for some period of time. So the main problem lied in this precompiled programs because they were compiled and distributed by their software developers, and software developers normally were normal people. They made mistakes, and these mistakes in implementation and design, they introduced different really nasty bugs. Yeah, so I will most probably give you a link in the end of this section for the issue of Frack magazine that first introduces the stack smashing techniques that were basically allowing you to run your own code by exploiting an input handling vulnerability of a binary program. So the specifics and the internals of these bugs are really highly technical. Yeah, so stack overflows or use after free, they are more or less comprehensible, but there are different techniques that are dedicated to circumventing security controls that were introduced by Microsoft in order to prevent these vulnerabilities from being exploited, and these are already really highly technical. So return-oriented programming, for example, that is aimed at circumventing different techniques of protection like ASLR, for example, they are really hard to automate, and for each exploit, this sandbox escape and the SLR circumvention, they are really hard right now. But back in the day, that was quite easy. So just by fuzzing some, by providing random combinations of input data to a program, at some point you could have caused an error in its execution, and the program would just crash. Yeah, so this fatal error that happens while fuzzing the specific software, it might indicate that somewhere your input have overwritten the code part of memory used by this software, right? So you can imagine that as the software running in memory and having its code stored in some specific area, right, in the code block. And there is the data block that is dedicated for static and dynamic data used by this program. And dynamic data means that this can change during execution. So these are all the variables that are used by the program. And if the variable is of varying length, as a string, for example, or an array of objects or variables, yeah, and if you can provide an unlimited amount of data when asked for the value of this variable, yeah, and the software developer doesn't think beforehand about limiting the buffer used in order to read this value from your input to the memory, you can overwrite the buffer, overwrite the stack pointer, and by basically providing the addresses of instructions that you have just successfully put in memory, you can intercept the execution of the program and start from the place you have specifically created for this act of exploitation. So I'm trying to explain it in the very figurative terms, but the actual exploitation is really time consuming. So most probably we will skip that for now, but you have to know these classes of vulnerabilities and what they generally mean, right? So stack corruption or buffer overflow is this writing of a piece of memory that temporarily stores the pointer, the instruction pointer that that actually points to the next instruction that has to be executed after the current subroutine is completed. Okay, so this part of program is completed and the program execution returns to the stored address, and you have to make it be different from what it was when the subroutine has started. So this is the overall approach to stack corruption, stack buffer overflow.